Space exploration is driving a rapidly growing industry, and innovative companies are eager to launch products that improve the quality of life for the interplanetary travelers of today and tomorrow. One aerospace company came to DornerWorks for help developing a solution that would enable Ethernet networking for astronauts aboard NASA's Artemis missions to the moon and beyond. With a foundation of radiation-hardened RTG4 FPGAs from Microchip and RISC-V softcore processors, DornerWorks engineers helped that company reduce one of the biggest barriers space travelers face when trying to communicate with loved ones and colleagues back home. DornerWorks engineers have since implemented this solution into Microchip's PolarFire FPGA. In this interview, we will hear from DornerWorks FPGA engineer Brian Douglas, who ported a version of DornerWorks 1 gigabit Ethernet switch IP targeting the RTG4 FPGA to the PolarFire.
I ported an RTG4 design, which basically involved regenerating some IP cores that are part of the Microsemi library. Some of them were basically when I opened the design and in a project set up for the PolarFire, there was very little work to do to move some IP into PolarFire. My recollection is, open a wizard and press a button that, bring up to or make compatible with this part. There were a couple others where I had to get a little more complicated. In particular, the clocking circuitry, because that's sort of a more complicated part of what the RTG4 does because of the triplication for redundancy in the clocking network. So that is a different element, so I had to create a new one. But it wasn't that big of a deal. And, there were a couple other things. A couple interconnects, AXI interconnects, I modified slightly because just the PolarFire IP core tool set is a little broader and deeper than that exists for the RTG4. The RTG4 is a special case for space, so it doesn't have all of the bells and whistles that you can have on the PolarFire.
What are the main differences between running DornerWorks Space Switch IP on the RTG4 FPGA and the PolarFire FPGA?
RTG4 is a rad tolerant part, but its level of rad tolerance is higher. The PolarFire target I aimed for was a commercial PolarFire part, but it is the same. Basically, it's a simple conversion to go from that commercial PolarFire part to the PolarFire rad tolerant part. So the idea would be that when you're working with development cards on the ground, some of those settings that you might care about, temperature ranges, the rad ranges, you could actually build for in the tool. You could target the rad tolerant part. The PolarFire rad tolerant part is a slightly different environmental profile than the RTG4. I think they're both sort of low Earth orbit targets, but the RTG4 is, I think, meant for sort of more longer term missions and maybe a little further out into space. And there's some things you could do with the logic and with the system to increase its tolerance. The PolarFire RT is aimed to be sort of higher density, more functionality, but the trade-off there is that if you can put more stuff and you could go faster, then your rad tolerance sort of decreases.
How unique is DornerWorks Space Conformant Gigabit Ethernet Switch IP?
As far as I know, there is no such IP targeted for space. This work was part of an effort under NASA for Orion, and it has the twin goals of being a high performance 1 gigabit switch, at the same time being low power and being rad tolerant. And that's a heavy lift. So I think what we attempted, there's still some work to be done to get it all the way there, but it's been an amazing learning experience, and we definitely have something here that no one else has.
How did people in space access the internet before DornerWorks Space Switch IP?
This is a kind of a new thing. So I think there were different derivations, different bus types. 1533 comes to mind. Spacewire is another architecture that's been used, but those are sort of kilohertz rates. They're highly reliable, but they're slow. Spacewire is standard, but I think the notion that, and this is happening across a few agencies in the US government, the idea is they'd like to be able to pick up commercial equipment and perhaps do what they can to make that commercial equipment rad tolerant and be able to plug it into their network as is. They'd like to be able to buy commercial equipment for test and things like that and just plug it in. Some of the things that have been in use are peculiar, or they're proprietary, they're specific to sort of the big companies, that they've developed these bus architectures for particular things, for a missile, for aircraft, for rockets, so for satellites. So they're trying to make use of what's available out there in the commercial world. Their issue is that terrestrial networking was never designed for high reliability. Ethernet, the idea was a endpoint will send a message and it doesn't know whether it gets received or not. And so in order to solve that, a protocol is added on top that says, I'm going to send a message and I'm going to expect a reply that says, hey, I got the message. And so at this point, there are quality of service protocols on top of just basic Ethernet. And those are other features that we're working on adding to our switch product. But those sorts of things are resource intensive, more chip resource, more board resource, in that you need more memory, maybe other devices on the board itself. So that's going to increase weight, power. They call swap. So, there's some trade-offs there. And what they'd really like is a very high reliable network that is composed of sort of commercial off-the-shelf equivalents that have been made rad tolerant. And I think that's the goal. I'm not sure how soon they're going to get there, but that's the pursuit right now of a lot of the US agencies.